Hi, everyone. This is Jay here from Interview Query, and today I'm with Ved. Ved is currently a PhD student at which university, actually?
University of Nebraska at
University
Lincoln.
of Nebraska. Okay, great. And he's working at LinkedIn currently as a machine learning research scientist intern. And so, Ved, I'd love for you to introduce yourself with your background and tell us a little bit more about how you got into data science.
Okay, thank you so much, Jay. Hi, everyone. My name is Ved, as Jay mentioned, and currently I'm doing a research data science internship with LinkedIn, where we are looking at some A/B testing approaches with that are deeply entrenched in the software development cycle. I'm currently doing a PhD in statistics, where my research mainly focuses on recommendation systems. And one recurring problem in recommendation systems is how do we incorporate multitude of features that are there. There are many type of features that can be there. And I also work in computer vision. Previously, I completed my master's in stats from University of Minnesota, and I worked as a data science intern before this at Travelers Insurance, Seagate Technology, where I was deploying some recommendation systems for some internal use. And I've also had a brief stint with Hennepin County, which is like the county office for the county that Minneapolis is encompassed in. So that's my brief background. I'm mostly interested in statistical concepts like A/B testing, recommendation systems, computer vision, but the field is so wide that I feel at some meta level, these are all connected, and that's about me.
Yeah, definitely. I'm sure that, they're A/B testing two different pictures right now as we speak on unsuspecting demographics to get them to click more.
Oh, I
So
see.
we're in the right field.
Yeah.
For the question that I have today for this mock interview, wanted you to ask was actually around a job board. So kind of similar, but essentially this is kind of our weekly challenge question. So a PM wants to build a related jobs feature on every individual job description page, right? So this would be kind of like if you look on Indeed right now, there'd be like a job description, and then on the right side, it'd be like related jobs that you could apply to. And so given that you're presented with this scenario, you quickly realize that there's millions of new jobs posted every single day on the job board, and finding the top 10 related jobs for every single job posted each day could be extremely inefficient. The question is, explain a system or a method that could solve the problem of finding the top 10 closest related jobs for millions of new jobs posted every single day.
10 jobs. Okay. Yeah, that's a great question. And I think a very applied question that many job boards could benefit from. Before I dive into the answers and kind of how I would attempt this, one question I had is this particular question talks about retrieval of top 10 jobs from the jobs that were posted on that particular day. Could the jobs which have been posted in the past, are they out of the table? Like, are we not considering the jobs that have already been posted and it's only advertising the new jobs that have been posted today? Or are we also open to some previous jobs that might have already been posted?
Yeah, let's say that for every single job, we want to be able to consider all the jobs that have been posted in the past like month.
Okay.
So we'll
Okay.
use like the past month as like a heuristic as it being
Okay.
active,
Okay.
but basically any kind of active job.
Okay, any kind of active jobs. Yes. Why I ask is because some of the jobs that have been posted in the past, it would have been time for a lot of the other users to interact with those jobs as well, which kind of gives us crucial information and patterns to mine as compared to some jobs which have been only posted today. Because if we are trying to find jobs which have been only posted today, we lose out on any sort of user and item interactions, because probably not a lot of people have interacted. So the only way you could go about retrieving new jobs is through these embeddings and finding some vector similarities and all that. So, okay, using your info of using a heuristic of the last 1 month, we have to find the related jobs that would be there. So let me try to approach it with, is it okay to share a whiteboard
Yeah,
and kind
definitely.
of just draw some stuff? Okay.
Yeah.
Hopefully this works. Okay. So how I'm envisioning is I'll try to, because I think it is also important to see whether the company or the particular job board who has this project has the functionalities and capabilities to attempt this problem in the way that I'm doing right now. So if at any point of time you feel that, oh, maybe they do not have data like this, or maybe this is not what they can do with the current resources, just let me know and we can probably go down some other path. But I'm assuming that at least what they have information on is the users are over here and the particular jobs are over here. So this is just a matrix of a user and a particular job, right? So maybe
Yep.
we have user number one, user number two, up till a lot of other users. Here we have job ID number one, job ID number two, till job ID number 100. And I'll tell you a bit about why I'm going this route, because you had, the question mentions that there are NLP concepts such as bag of words or word embeddings. Um, I was just wondering, is there any, like these are the methods that have been tried and we want to look at something new, or using those NLP concepts is also fair game,
Yeah.
is
Yeah. Yeah.
something I
Using
had a
any
question.
NLP concepts are fair game.
Okay.
I think those are just kind of examples. Bag
Oh,
of
okay.
words,
Sure.
cosine
Right.
similarity are all things that
Right.
are
Okay.
common.
Sure. So this, what I'm talking, the algorithm that I'm talking about right now is just the classic collaborative filtering, the matrix factorization algorithm. So let's just assume, and you can tell me if they have data like this or not. Let's just consider one particular user. We would have information on, let's say, whether this user applied to job number one. Maybe he did not apply to job number two. Maybe he did not apply to job number three. He applied to something over here. And likewise, so would it be a fair assumption to assume that they might have information like this?
Yeah. Yeah. So I guess to get the information to this, yeah, you're right. So they would definitely have this information because it's the
Yeah.
activity, right? But they'd only
Yeah.
have it for all the previous jobs, but not.
Yes, they would only have it for the previous jobs, like the last 30 days. And yes, that's a good point to bring up, because we always have to think about who are the target population that we are trying to propagate or advertise. So this particular explanation will only aim for jobs, let's say, which have been there. Maybe we can put a heuristic, like all the jobs which have had at least one interaction, something like that. So maybe this is all the jobs which at least have one interaction in them. And perhaps we can discuss how to tackle the latest jobs, because they would not fit in this same matrix factorization way. We would have to look at just some brute force NLP stuff for that. But this would give us like a nice way to attempt at jobs which have already been there. So
Yep.
what I'm thinking about this is, there are so let's say this particular user has already applied to job one, has already applied to job 70. There are a lot of missing spaces over here, right? We neither have zeros over there, because zero would mean that he did not apply. This is an example of explicit feedback, where we only know the positive occurrences between the user and the item. We never know which job he did not apply to, because maybe he was interested and he was just not aware that such a job is there. And that's the beauty of recommendations. So the goal here, if I were to explain it simply, if we could come up with such an algorithm that helps us fill these empty spaces with a probability, like maybe 0.8 or 0.9, then we would have a clear-cut probabilistic interpretation that, okay, if we recommend job number 68 to user number one, perhaps he would like it 90% of the time. Or his liking, his affinity to this particular job is 90%. And I agree. The goal is not to target a user, but to target a particular job and retrieve similar items to that particular job, which I will get to once I talk about the algorithm. But these kind of algorithms helps us address two major holy grails in recommendation. Retrieving similar items to the product, but if you want to do some more targeted search, right? Because whenever someone pulls up a particular job, we know who that person is. We know what job that is. So we could attempt it from either way, from a user perspective or from an item perspective. So I think how this problem is framed is from an item perspective, but we can also attempt it from the user perspective. And the interpretation of that would be if you give recommendations to the user, which is tailored to him, that would be a more personalized recommendation. Okay, so do you have any questions, any other directions you would want me to address? Else I can start talking about the algorithm a little bit from high perspective.
Yeah, so I guess to summarize, if I'm understanding correctly, like if we can apply these measured characteristics, we can get more features for the jobs and then user characteristics as well.
Exactly.
How does that, I guess, then apply back to kind of the related jobs problem?
Yeah, exactly. And I'll get to that. I'm trying to see how I can clear this. Let me see. So let me rephrase your question. You mentioned how will we use this algorithm to make the recommendations or finding the jobs for the relevant jobs. So let's try to get at that. So the goal for us is we have a big matrix. Let's say, let's call the dimension over here users. So let's say there are m number of users and there are n number of items. So the dimensionality of the matrix is m by n. So the matrix factorization, what it does is it comes up with two matrices, which are of the dimension m by f. And it also comes up with another matrix which has dimensions f by n. So when you take a matrix multiplication of both of them, you come back to the original dimensions, which is m by n. So once you find these lower, so these are also matrix decomposition, because what we are trying to do is we are trying to find two other matrices. So this matrix is known as the user feature matrix, and this matrix is known as the item feature matrix.
Okay.
Right? So you can see that the dimensions match. Basically, if I were to explain it simply, what we have done in this process, this is still high level, is we are basically telling the algorithm that we think a user as well as an item can be expressed by a f dimensional vector. So this algorithm automatically calculates these features. Obviously, there is some loss function, there is some sort of a stochastic gradient descent or any other optimization happening, but this is the crux of the algorithm. To understand the beauty in this algorithm, that just realize that the only thing we had going in was just the interaction. Let's say if you and I were the only two users, we literally only need to know what are the jobs you and I applied to. That's it. And this algorithm helps you create these abstract features for you and me, which motivates so many downstream algorithms. And that is why I like this, because we started with nothing. Now we know a lot about me. We know a lot about all the jobs that are there. And now literally sky is the limit. If we want to find similar users, we can find similar users. If we want to find similar jobs, we can find similar jobs. So that's like the high level of this particular algorithm. Yeah. So how, what would you like me to talk about how the training happens, or should we base the execution from this high level perspective? How would you like to proceed with the discussion?
I guess I'd be interested to figure out exactly what the, I guess, practical aspects are, right? Because we dived into
Yeah,
how the algorithm is going to work, right? It's
right,
matrix multiplication. We're
right,
taking activity from like the users and activity from
right.
the job, or not the activity, the users activity of the users on the
On the
jobs,
jobs, right.
right? And
Yeah,
then creating this now n dimensional by n
yeah,
vector, right? Or
yeah,
um, training set. And so how do we
yeah.
use that on, like, let's say a new job that comes in,
Exactly.
find a
So
related job?
yeah, so going back to our earlier discussion, we are only talking about the active jobs so far, and a heuristic filter we put on this was all the jobs which have had at least one interaction, and coupling this with the heuristic you told me last 1 month. So the filters, or the filter on the sequel is like last 1 month, at least one job. So after you run this algorithm, for the sake of simplicity and explanation, let's just consider we have 10 jobs to offer, or let's just consider we have 2 jobs to offer, right? Um, let's actually make it till 10 so we can motivate the example of retrieving. After you are done running this algorithm, all of these jobs will have a feature. So this is a vector that I'm making over here, and these have numbers filled in. These are abstract features which have been extracted. They don't have any like artistic meaning, like age or gender. These are just abstract features which we can think of as a secret encoding for that job. Job number 2 will also have a secret encoding like that. And job number 10 will also have a secret encoding like that. So this is actually not very different from how the embeddings work in deep learning. But the good thing about this algorithm is, if you know, a lot of the deep learning does not have analytical solutions. It's stochastic gradient descent. You have to make a bunch of passes through the data. You have to make some epochs over the data. But for matrix factorization, there are some analytical solutions, like basically matrix formulas, which you can just use and iterate over very few times in order to find all of these features. So just reiterating, all of these features are what matrix decomposition gives us, and we can call them item side features, which basically means some sort of abstract representation of my jobs. Okay, once we have all of these abstract representations, a very naive thing to do would be to look at a correlation matrix, right? Like what are the top 10 most similar jobs to item number, to job posting number 1, or job posting number 2, or job posting number 3, which actually is a challenge because you mentioned there are millions of jobs that are posted. So I'm assuming even with those filters, we will have quite a sizable number of jobs, and doing those similarity calculations is not trivial, right? Because let's say we have 1,000,000 jobs, the matrix would be 1,000,000 by 1,000,000, which is a huge matrix. And it wouldn't be a very sparse matrix, which will take memory to store, memory to look up, memory to calculate, causing downstream issues in latency and whatnot. So I have an ad hoc solution for this. Ideally, we would want to go the route of not maybe doing ad hoc approaches, but since there is a particular business requirement, we have to sort of find some hacks around this. So how about this? How about we take the idea of unsupervised algorithm to maybe make our lives a little bit easier and alleviate some of this problem?
Mm.
There are always some assumptions to modeling that we have to take. So if this assumption is tenable, maybe we can go through with this process. If not, we will brainstorm something else. So I am assuming this job board, let's say if this is Indeed or LinkedIn, and let's say we or you or I pull up one particular job description of a data scientist, right? So there is an upper limit on the corpus of jobs which might be potential jobs for this, because let's say a data scientist, you might not want to recommend something for a mechanical engineer in that, right? Or maybe for electrical engineer. The class
Yep.
of jobs is very, let's just say, finite. But obviously if we try to attempt it the manual way, it might be a lot of problem because there can be so many features. What do we stratify on? What sort of hierarchical rules or manual rules we make is difficult. How about this? Let's say, if you remember, we had n jobs. So we had n jobs and we had f features on those jobs, and these features have been extracted from this. So over here it is 1, 2, 3, 4. So for example, over here f is equal to 4. So now we have embedded every single job into a 4-dimensional vector, right?
Gotcha.
How about we just resort to some clustering algorithms like k-means, a very simple algorithm to cluster these jobs, right? Maybe we will find that, and we can look at things such as the very famous Cree plots and whatnot, which basically explain some sort of measure of how good the clustering is. So
Yeah.
so over here we have the number of clusters, and over here we have some particular metric. I wouldn't pretend if I exactly know what that metric is over here, but it basically tries to check, let's just put it simply, how good the k-mean is for this particular value of k. So I think that is some measure of how much is the variation explained between the clusters and within the cluster. So something related to that, but some measure of efficacy. So let's say if we found that there are 5 clusters in total, right? So now coming back to the problem, if someone tells us, hey, Ved, can you recommend some similar jobs for job ID number 1? We first map it back to the particular cluster. So let's say this is in cluster number 3. Then we have automatically discounted 4 of the other clusters, right? So that helps us in alleviating this problem of retrieval. I'm not saying that this is a foolproof way. Obviously, we would lose out on some good potential jobs that are there in some of the other clusters. But if the business comes to us with a requirement, we have to find some way of doing it. And this is like my way of doing it. So then it is pretty simple. Let's say we find job ID 1 belongs to cluster number 3. And then we do the same kind of vector similarity for only the jobs that are there in the cluster number 3, not in all the other clusters. So that's how you could look at things like just the cosine scores, retrieve the top 10 ones. But I am assuming the level of simplification that will be there with this approach is a direct artifact of how many inherent clusters are there in my job types. If there are more number of clusters, which will be automatically found out by some of these Cree plots for k-means, then the level of simplification we do is pretty significant. If there are 10 number of clusters, then we have improved our finding algorithm to the order of 10, which I think is a significant improvement. So in order to summarize my approach, the question you posed was, we are a job board and we have to retrieve some similar jobs to a particular job. And obviously there are many jobs, so we do not want to just resort to the brute force way of looking at the similarities. And my approach to this was, let's just first look at only the occurrence data, because one thing I have a lot of disagreement on in our data science work is there is hardly, I mean, this might happen, but I haven't seen it in my experience. People directly jump to very complex solutions like, okay, we have NLP, let's look at the data, throw in a bunch of NLP text mining stuff. But there is really no simple baseline to do that. So how would we ever know how significant of an improvement do we have over a simple technique? If a simple technique does the job, then by Occam's razor, we should be going with the simple stuff because it's easier to maintain, deploy, enhance. So the idea I told was, we will just take the user item matrix, apply algorithms such as matrix factorization to extract abstract features on items, which are the jobs, and users as well. Then we still haven't solved the problem of retrieval. We have only solved the problem of automatic feature generation. So we will use that to cluster. And when someone asks us to recommend a new job, we will just find which particular cluster that job belongs to, and then just make vector similarity matrix for that particular job and sort by the cosine similarity. So that's sort of my approach. I'd be happy to discuss more ideas, avenues, or any other questions you have.
No, that sounds good. So I guess my next question is more
Yeah.
on the practical deployment side.
Right.
So, let's say we attempt this, right,
Yeah.
solution. We get these jobs back. We get
Yeah.
like 10 jobs for every new job that gets posted.
Yeah.
Everything looks good. But how do we know if it's working well, right? How do we
Oh,
know, how
sure.
do we measure the efficacy of our like
Yeah.
strategy, right? Um, are we testing this offline beforehand, or are
Yeah.
we like just rolling this out in
Oh,
production?
yeah. That's a great question, because I think that's how we tie up the computer sciencey, machine learning, and deep learning with deriving some strategic insights with the use of A/B testing before we push these changes out. So, and the reason to that is actually very fundamental. Let's discuss some very common metrics, right? Let's just say root mean square error or average accuracy.
Yeah.
Sure, when we are doing the local development, testing out a bunch of models, what is our approach? We say, okay, I will test logistic regression, I'll test random forest, and whichever gives me the higher average accuracy is my model of choice, right? But the fundamental question we haven't addressed with this is there a one-to-one correspondence between the average accuracy and how the end user will perceive it? It's an open-ended question. I mean, sure, but the problem is the observational data that we had collected was not collected in a controlled setting. So making this sort of causal inferences can be a little bit of a slippery slope. So
Yeah.
coming back to the question of how would we know it is working? So first of all, we would have to discuss that there are two ways of knowing it is working or not. One is the local metrics, like the average accuracies, or in this case, accuracy does not make sense, because why I say that is, let's say we recommended job number 1, we recommended job number 2, and we recommended job number 10 to a particular user. Uh, Taking the average accuracy, or basically saying, okay, how many of the 10 jobs did the user actually take, is a bad metric, because our metric should have some sort of ranking intuition in that, because we should really give the mistake at the first position a higher penalty. Because let's say if I'm recommending you a movie at the very first position, I better be sure about it, because otherwise it translates to bad user experience. So there are many ranking metrics that we have to look at. Which metric, it's not important. What is important is understanding this concept that if you are making recommendations, usual metrics are not good. We should look at some sort of a ranking metric. So in order to do the local development, find the better algorithm. Obviously, matrix factorization has a bunch of different hyperparameters, k-means. We can do this sort of local development in order to basically come up with our best shot algorithm and streamlined process. But we should also try to at least attempt to see how the end user will perceive recommendations from this, right? So, I mean, I'm assuming since the job board already is doing that, there would be, let's say, the current standard of doing that recommendations, right? Be it just be some sort of a very simple way of retrieval or any other way of retrieval. We can take that. What we can do is, we at this point of time, we have to talk to the company. We have to talk to them. Hey, are you guys allowing me to maybe do a very small randomized study where I will put some groups in the control group? All of them will see recommendations from your current state of the art or whatever you are using. And let's do the second group show recommendations from this modified approach of matrix factorization plus clustering followed by retrieval. And then let's just basically use statistics to make some inferences, right? That would be getting into the inferential territory. So we have to ask them, can we do things like that? Do you have the facilities? Do you have the budget? Do you have the patience? And more so, do you have the interest to do that? Then that's the gold standard. If we can do an experiment, there is nothing better than that. However, if we are not able to do that, we can also do something known as a causal analysis, which is our best shot at recreating an experiment with the current data that is there. So at this point of time, in order to see if this thing is actually working, there are two ways. One is from the modeling aspect, one is from the end user consumption aspect. And the second, I would say, is more important. So I would ask the company, can we do a small randomized study? If they say yes, that's the best thing. The inferences from there are very solid and have a sound theoretical underpinning. If not, we can go at some more ad hoc ways. But obviously, any sort of qualitative statement I make over there would have to be taken with a grain of salt, because we have not randomized the groups in a controlled fashion. We are only trying to recreate it. So that would be my two approaches, and happy to discuss if we want to drill down on either of those.
I guess my last one would be, what if that this is a new feature that's not launched yet. Let's say that we want to build this new feature.
Okay.
And there's no like prior matching algorithm, there's no prior related jobs. What do we compare it to now to actually set a standard for success?
Okay, so do you mean that this feature is not directly there, as in the sense that the company is not doing this kind of thing? Like they are not retrieving the top 10 jobs, and this is the very first time something like this would be attempted. Is it like that?
Yeah, like that. So it's like this is the first time they're trying it.
Okay,
and
awesome.
Then they want to build this feature for the first time.
Yeah, for sure. I mean, yeah, so that kind of limits our options, but not our motivations and excitement to do this. In that case, we can at least do our due diligence to do a best local validation. That is having a sound validation set and a test set and finding our best set of hyperparameters and all that. So that is only for the modeling aspect. If the company is still interested in knowing how the end user will perceive it, that becomes a little bit tricky, because we do not have current standards to compare it to say that, okay, this would be an improvement. But how I would attempt that is through an iterative process. So what I would tell them is, obviously, you want to implement this feature, so you guys do realize there is some definite utility and ROI that you might derive from such a feature. So how about we do this? We come up with, let's just put this box. This box is everything we have done so far. Any type of model, any type of retrieval, any type of clustering. Obviously, at time step 0, they do not have any product. So this decision can be boiled down to a binary decision. And I will tell you my opinion on this, and you can also tell. Rolling it out to the 100% audience is never a good strategy, because we do not have ways to scale it back. We do not have ways to stop the experiment if we notice negative effects. So how about we start with some gradual stuff? Let's just first show it to 5% or 10% of the users. At this point of time, I don't think we would be able to compare it with any other state of the art, because there is not one at the moment. But we can get a good enough sense of, okay, is it too bad? Is it not that bad? Is it working? By just looking at some descriptive statistics, right? At this point of time, more so, we are just making sure that we have some sort of sanity check. And so we roll it out at T0, we show it to 5%. If things look good, we take it to 10%, 20%, 30%. And at that point of time, we would start to gain some data in an intelligent fashion of how the end user is perceiving it. Because if you take a good sampling of the users, we do not need to show it to everyone, right? The analogy to that is, if we are sick and we go for a blood draw, they do not take our whole blood to check if we have an issue or not. They just take a good enough sample. And then from there, they are able to tell a lot of very important stuff. And provided we are doing this initially, making sure this is working, at time step 1, now we have a current state of the art, or let's just say current state of execution, whatever we have right now. So from the second iteration, we can start to do an A/B testing as well. Here is what I have so far And now we can start to improve and throw in some baseline approaches, throw in some modified approaches, and really proceed in a data-driven way. We do not go in with any sort of philosophy or any sort of biases that we might have of what we think it works. It would be a very data vetted way. We will only proceed if the data tells us to proceed. If not, we will all collaborate together to think of how we might address this issue. So in order to summarize, how we will know if it actually works, if the company does not have the product, we will come up with our best approach, and at time zero we will start to show it to 5%, 10%. If things look good, we'll gradually scale it up. Once we have made the advent or the start or initiation of this method, from the second iteration on, we can resort to small scale A/B testing in order to make very strong inferences on whether this approach is good. And A/B testing can also help shed light on a lot of the key processes, right? I think of this as a giant car, and doing the A/B testing can tell us whether the problem is in the engine, whether the problem is in the wheels, whether the problem is in the transmission. So it actually gives us really good ways to diagnose what might not be going right. And in doing that sort of diagnosis, we are not resorting to any bias of the data scientist or any preconceived notions. We are asking the data to guide us in this journey of continuous improvement so that the company benefits from this sort of R&D. Any sort of R&D that we do, which does not have tie-ups with how might we use that institutional memory and information, would not be a good research and development. So this provides a seamless strategy going into the future.
That's interesting, actually. I think having a process for strategizing how development goes out is important, given the fact that many times, almost all the times, actually, it's always iterative in its approach.
For sure.
Right? You don't actually get the best result once you immediately launch your classifier.
Yeah.
I would say one additional point is we could try like running some random seed algorithms, right? So you could seed it with like completely random jobs.
Yeah.
And then see if it actually performs better.
I would say that's a very good point in order to bring, like, let's say, because obviously we want to be better than random at least.
Yes.
Like how far apart we are from random will tell us how we are proceeding. So I really like that point. Let's just recommend random stuff, even if, so that would actually give us ways to do this sort of A/B testing right from the onset. We would just say, okay, let's first at least try to prove that what our data scientists came up with is better than random, because if it is not, then we have some real issues over here. So let's say at the first iteration, we use your idea to have one group who sees random seed recommendations, another group which sees our recommendations, then at least we have a winner at the first stage. So now we just proceed in this round robin format. Whoever wins in the previous iteration goes into the next stage of development. And now we have it compete with another variant of the algorithm. I think that's a great strategy, which actually decreases this development duration by however much the gap between T0 and T1 is. So I really like that idea as well.
That's good. Yeah, always having a baseline against something is good, especially as the model probably continuously retrains, right?
For sure.
Bias or go in a different direction.
Yeah. No, but these are all really interesting problems at the heart of recommendation system. I just feel like recommendation system is, I'm not sure if it is a broadly studied topic within machine learning, but I feel it just kind of gives us so much to work with and so many different directions to go on depending upon what the business uses. It helps us find similar users. And just like to share one small point in a few minutes. I took a recommendation system class, and our professor told us that only making recommendations is not important. And the reason he told is, let's say we go to Walmart and we paste on every single cart, hey, I am recommending that you buy bananas and milk. That would be a pretty strong recommendation, right? Everyone buys bananas and milk. But whether was it a useful recommendation? Absolutely not. They would have bought it anyways.
So knowing the intention of what the user would already be doing, we need not recommend him that stuff, but what he probably has an inclination for is really the sweet spot. And this is open-ended. How would we go about mining that sort of attention? And one solution to that was we always explain our recommendations. If you look at Amazon, if you look at Netflix, they always make efforts to tell us, okay, we are recommending you this coffee machine because you just recently bought coffee beans, or we are recommending you this particular movie because you recently saw this movie. So explaining why we are making a particular recommendation helps the user relate to this recommendation and makes him more amenable to consume that recommendation. Otherwise, they feel that the recommendations are sort of in your face recommendations, like the company or the product is forcing me to take this, and that sort of creates some apprehension. And obviously, this is just my hypothesis, working in this field for some years, but these are some of the sort of next step questions to address once you have a basic system built.
Yeah, definitely. And I think that it's almost like second order effects, right? Because if the first recommendation is bad, then
Right.
you're not likely to go downstream
For
and use
sure.
the recommendation again. But if it's good, then it can create a cascading effect on its own.
Oh yeah. If we are able to capture their attention and interest right when they first start to interact with our recommendation system, we might also be able to hold on to those users, or otherwise we might run the risk of them not coming back and interacting with our system, which would be a loss for the company.
Exactly. Awesome. Cool.